Alright, so we're continuing in 5.1. We're taking a look down here at this curve from 0 to x squared. We want to try to estimate the area under the curve. And we can't really use geometry in this case. So instead, what we'll do is we'll come in and we will estimate the area using rectangles. And so if we're estimating from 0 to 1, just for a simple place to start, we'll use 4 rectangles to do the estimation. Okay, and so we divvy up the interval from 0 to 1 into 4 pieces. So that means the length of each piece will be 1/4. Oop, 3/4. Okay, and now the question is, what should the height of each rectangle be? And so we have a choice here. And so just to start things off, my first choice will be to use right endpoints. Okay, and so what I mean by that is for the right endpoint, we're going to look at an interval, and we'll always choose the right endpoint to figure out the height. So the first height will be there, the second height would be here, the next height would be here at 3/4, and the next height would be here. Okay, and so we can see that the area of these 4 rectangles will be an overestimate, but let's go ahead and just see what these values are. So this height is going to be 1/4 squared, this height will be 1/2 squared, this height will be 3/4 squared, this height will be 1 squared. So we have let's see, the length is 1/4 for each, right? So the area of this first rectangle is 1/4 times 1/4 squared, plus 1/4 for the width times 1/2 squared, plus 1/4 for the width times 3/4 squared, plus 1/4 for the width times 1 squared. Good. And so you might notice that you could factor out that 1/4, right? And so we could say that's the 1/4 times 1/4 squared plus 1/2 squared plus 3/4 squared plus 1 squared. Good. If you punch that into your calculator, you get 0.4687, or thereabouts, 4687. Good. Now, that was an overestimate. So let's see if we can draw that again here. So suppose I use left endpoints instead. And so what are my left endpoints going to be? Well, for this first interval here, the first left endpoint will be 0. And so the height is going to be 0. And then this one, the height will be given by 1/4 squared. For this one, be 1/2 squared. For this one, be 3/4 squared. And so now we can use this as our estimate of the area, and you can see that that's going to be an underestimate. And by the way, it's an underestimate because our curve is increasing, right? And so that's just an observation. So if we make this new estimate, we get 0 squared plus 1/4 squared plus 1/2 squared plus 3/4 squared. Okay, and then if we punch that into the calculator, we get what, 0.218. Good. Now, again, this was the left endpoints. Oh, let's call this L sub n, L sub 4, in fact, and this we'll call R sub 4 for right and left. Okay, if we take a look at a chart of the left and right endpoint areas, we can kind of see what's happening here. Let me pause while I write down this chart. Good, so up on this chart here, I've just labeled where we were. So on this first line, right, we were estimating the area using 4 rectangles, and we saw that using right endpoints, right, oops, what is that coming out? Right endpoints gave us this number, and left endpoints gave us this number. And the true area then is somewhere in between. And so as I increase the number of rectangles, here I've got 20 rectangles, and using left endpoints I've got 0.308. Right endpoints for the heights I've got 0.358. Using 50 rectangles and left endpoints for the heights, I've got an area overall of 0.323, and then using right endpoints as the heights for each rectangle, right, I've got 0.343. And so you can see what's happening as we get bigger and bigger. The left and right endpoints are actually both converging to the same number, and so we would say that the area using n rectangles looks like it's converging to 1/3. Good, and so we would say that 1/3 is the area under the curve. It's the value that we get when we take the limit as n goes to infinity. Good. Now, let's see if we remember our Appendix E. Whoops. Let me pause this for a second while I set things up. Okay, so using n rectangles with right endpoints, what are my right endpoints going to be? What's the area going to be? Well, the first right endpoint is going to be 1 over n, right? The next one's going to be 2 over n. The next one's going to be 3 over n. And so at the very end, right, we'll have an n over n for the last right endpoint. So the height is x squared, and so, oh, by the way, the overall width of each rectangle, using n from 0 to 1, it'll be a length of 1 over n, right? If we want n equally spaced points there. Okay, and so overall then, I'm going to have a width of 1 over n times a height of 1 over n squared, plus a width of 1 over n times a height of 2 over n squared, plus, and the last one, I'm going to have a width of 1 over n times a height of n over n squared. Right? Whoops. Sorry about that. Things flew away on me. So let's see where we are here on our picture, just to be sure we've got this. Okay, so from 0 to 1, I've divided this into n pieces. And so I just take one piece and I'm using the right endpoint for the height. Right? And so the width is 1 over n. And then the height is I over n squared, right? Whichever I is. So I is running from 1 to n here. Okay, so therefore the ith area is just going to be 1 over n times I over n squared. And so the overall area using n rectangles, right endpoints, we can write as the sum from I equals 1 to n of 1 over n for my width times I over n squared for the height. Good. Now I can simplify this. Let's go ahead and simplify that a little bit. I'll go ahead and take out the 1 over n cubed, right? And then we'll multiply that times I squared. And in fact, this doesn't have anything to do with I, so I could factor that all the way out. And so this is 1 over n cubed times the sum I equals 1 to n of I squared. And now using our formulas from page A37, do you remember what that formula was for that one? Well, I'll write it down for us. 1 over n cubed, and this was n times n plus 1 times 2n plus 1 divided by 6. Now what does this number represent? This is the area using n rectangles with right endpoints. Right? And so how do you find the area for the function from 0 to 1? Well, that would be the area is going to be the limit as n goes to infinity of our expression here. N times n plus 1 times 2n plus 1 divided by 6n cubed. So if you look at the leading term of the numerator, it's a 2n cubed divided by 6n cubed. And so this is going to end up going to 1/3. I'll let you, you could expand this out and use L'Hopital's rule if you wanted to, or you could divide top and bottom by n cubed. Okay, now we're not going to do this until the next section formally, but I just wanted to give you kind of an idea of where we're heading. So in the next video we'll try to set this up more generally. We'll kind of go back to scratch, and then we'll take a look at some examples. See you then.